Specifically looking at solving inequalities. Okay, inequalities, because they are not equal, always add in a little extra element that kind of makes this a little tricky and quite honestly a little annoying. But that's okay. We're gonna work it out, and I will show you what makes it so tricky. So the first part of it is still the exact same as what we did on the other side. You still need to figure out your common denominator here. For example, I know I'm going to multiply this top and bottom by an a plus 1. I know that makes my denominator, my common denominator, a plus 1, which tells me that a cannot equal a negative 1. Okay, again, that's going to be actually more important almost this time than last time. So you're going to have to use it. After that, you're just going to, again, solve the top. So 3 is greater than or equal to 3 times a plus 1. If you distribute this, that's 3 is greater than or equal to 3a plus 3. When you solve, 0 is greater than or equal to 3a. Divide a is, and I'm going to divide and rearrange, so I hope this doesn't freak you out. Actually, here, I'll do it in 2 steps. So 0 is greater than or equal to a, or, as I prefer to see it, a is less than or equal to 0. Okay, well, that's what you got when you solved it. But quite honestly, you need to check, because there's more to this inequality than just that. And the reason for that is because this point that a cannot equal. So the way we do this is we put these two numbers on a number line. So like here's 0, here's a negative 1. We need to pick points that are in between it. Okay, so in between. So, and around it. So I'm going to pick 1 here. So these are the points we found. I'm going to have to pick negative 1/2 here. And I'm going to pick just negative 2 there. We take those points. I should put this one up here. So we take those points and we plug them into our original equation and see if what we get is true. Okay, so check it out. If I have 3 over 1 plus 1 is greater than or equal to 3. Is that true or false? Well, that's 3 over 2 is greater than or equal to 3. That is not true. False. So that means that that side of my equation, this, is not going to be part of my inequality that makes it true. Okay? I'm going to skip over here to do negative 2, so let's check that one out. 3 over negative 2 plus 1 is greater than or equal to 3. Okay, well, negative 2 plus 1 is negative 1. That would be negative 3 is greater than or equal to 3. Also false. Okay, that is a pretty good indicator that the middle of this is going to be what makes it true. But we'll go ahead and check it out. 3 over negative 1/2 plus 1. Well, negative 1/2 plus 1 is a 1/2. 3 divided by 1/2, if you think about it for a minute, 3 divided by 1/2 is actually 6. So if I have 3 things and I cut them in halves, I have 6 pieces. Is 6 greater than 3? This is true. So my solution is going to be the area in between those 2 points. Okay? And because this had an equal sign on it, I am going to bubble those in. And that tells me that my actual solution to this equation is that negative 1 is less than or equal to a, which is less than or equal to 0. Okay, I think you see how quite annoying that is. I'm going to skip around. I don't think I'm going to work all these just because mainly look at how much room I needed. So if I come over here and work this question, kind of starts off similar. I need that common denominator, a 2, a 5, and a 3. The only way you could make those work is 30. So 30p specifically. So I'm going to multiply this one by a 15p. I'm going to multiply this one by a 3, not a 15p, just a 15. This one by a 3. This one by a 10p. So 10p. So again, that makes 30p my common denominator. If I set that equal to 0, p cannot equal 0. Okay, again, I'm going to have to use that for my answer here in a second. Ignore the denominators and solve the tops. 15 plus 12 is greater than 2 times 10p. So that's 15 plus 12 is 27 is greater than 20p. When I solve this, gross, who likes fractions? 27 and 20, I don't even think that's going to reduce at all. That's gross. But that's what you get. So p is, and again, I'm going to rearrange this because I just like to have the p on this side. So p is going to be less than 27 divided by 20. That really just feels wrong, but that's what I'm going to say it is. So again, check your answers on a number line. So I'm going to come up here this time to do it. So here's 0. 27 over 20 is like, 1 point something. So a good number to pick in between, I like to box these just so I know those are my real numbers and I'm checking these other ones. Are 1, let's do -1, and let's do 2. Those are nice and easy. So again, let's plug each one of them into your equation. So if I have 1 over 2 times -1 plus 4 over 5 times -1 is greater than 2 over 3. So since this one does just have numbers in it, you can leave it like this if you want to use your calculator. But to be honest, it is going to be easier for you if you check it using like your common denominator already. Okay, so I'm not going to do that this time because I think we can tell right here that if this is a negative number and this is a negative number, that there's no way it's going to be greater than 2/3, so that this one's false. Okay, if I plugged 1 in, 1/2 plus 4/5. Okay, 4/5 is already greater than 2/3 if you know anything about fractions. So if you have half of something and you have almost all of something, it's definitely going to be greater than 2/3 of something, so that's true. If I did 1 over, and I don't even actually, hold on, I might have done that wrong. Oh no, I didn't, sorry. And then if I did the 2, so that would be 1 over 4 plus 4 over 10 is greater than 2/3. Now this one you might have to think about that a little bit, 1/4 and 4/10, 2/3. But if you found your common denominators there, like you should, you would notice that that is actually not true either. This is, I don't even want to do it, but it's not true. I'll do it for you though. I'm going to cheat and use a calculator though. 1/4 and 4/10 is 0.65. 2/3 is 0.6 repeated. So that's not true. So again, just like the last one, your answer is going to be that P is in between 27 over 20 and 0. Okay. Sorry about that one I wrote there. Okay. I think that's pretty good and kind of get the gist. Be sure you check it. I know on those, like, it seems very unnecessary, and you are wanting to tell me that that's always going to be true. But if you do another one, and I guess, I don't want to, but I guess I will do one more. Meh. No, I don't want to. But if you do another one or two, you might see that sometimes that's not true. For example, on the example problem they did up here, when they solved this one, and they did all their work, they got 2.2. When they checked it between there, it was actually the outside parts that were true on this one, not the inside parts. So again, you really have to check those answers, okay? It does make a difference.